solving right triangles. This is almost going to be a redo of what we did in class today, but I do have different examples for you to see. So feel free to add these to your notes, continue them. You don't have to count them as example 1, 2, and 3 like I have them here. Just add them to what we have. So all this we already wrote down today. So we have solving right triangles. You're identifying all three sides, all three angles. Pythagorean theorem you can use when you have two sides and you want to find the third. And then we have SOHCAHTOA. This is all stuff you should also add to your foldable. I'm going to write this out. You want SOHCAHTOA. You probably want to put opposite hypotenuse and adjacent like I have here. You want to make sure you have Pythagorean theorem written down. And then you might want an example, or maybe you might want how to use your calculator, something like that. Whatever you have room for, you have one box for solving right triangles. So hopefully you have your calculator. Practice going through these if you want to. Once I have the triangle written for you, pause it, see how you do, and then you can watch the video to see if you got it correct. That's probably a very good way to go about this. So to solve the right triangle, let me fill in some sides here for you. Let's say that this is 12. Let's say this is 13. And let's say that that's all I am giving you. So we have two sides given. Don't forget, the sides are opposite their angle measure. So the only angle we're given is 90 degrees. I am given side B is 12. I'm given side A is 13. So I can go through and I can use the Pythagorean theorem. So I have 13 squared plus 12 squared equals c squared. And c does happen to be my hypotenuse because it is across from my right angle. So 13 squared plus 12 squared, I'm plugging into my calculator. I get 313 equals c squared. So I'm going to square root 313. And I get 17.69. So I'm going to use 17.7. So I have all three sides. Now I have two angles that I need to find. So I am going to have to do a little bit of work to find those two angles. I'm going to find angle A first just because A comes before B. So I want to find angle A, which means 12 is adjacent and 13 is opposite. So if I think of SOHCAHTOA, SOHCAHTOA. Opposite and adjacent. What uses opposite and adjacent? Tangent. So I'm going to use tangent of A will equal 13 over 12. So to undo tangent, I want the tangent away from A. I can't just divide by tangent. I need to take the inverse of tangent. So I end with A equals tangent inverse of 13 over 12. So I'm going to use my calculator. I'm going to double check that it is in degree mode. And now I'm ready to go. So tangent inverse, which is second tangent. Don't forget to use parentheses. 13 divided by 12. And I get 47.29. So I'm going to say angle A is 47.3. Now I'm going to subtract that from 90. 90 minus 47.3 is 42.7. And your angle measures, they really, really do need to add up to 180. You should not be over, you should not be under. Whatever your decimal is, that's what you should subtract from 180. Don't use the decimal in the calculator for that one because it does need to equal 180. All right, so there's the first one. Let's do another one. So in this one, again, it would be a good idea. Stop, pause, write this down, try it on your own, and then start the video back up. So let's write down what we know. We know angle A. We know angle C. So from there, I could get angle B. 90 minus 30 is 60. And I know side C is 10. So I do need to find a side. My angle of reference is going to be angle A. So what do I know? I know 10 is my hypotenuse. Here's my opposite. Here's my adjacent. So I'm going to write down SOHCAHTOA again. Okay, we're given the hypotenuse. So I am not going to use tangent. I have to use sine and cosine. I'm not going to use the Pythagorean theorem. I want a number that's pretty darn close to being accurate. So I want to stay away from decimals. So I'm going to start with sine. Sine of 30 degrees equals opposite, that's what I'm looking for. Opposite happens to be side A, so I'm going to use A. And my hypotenuse is 10. Oh, well, this is nice. I just need to multiply both sides by 10 in order to get rid of my fraction. So that's gone. So little a will equal 10 times the sine of 30 degrees. So in my calculator, I'm going to just plug it in like that. 10 sine of 30. And I get a nice number of 5. So little a is 5. Now, because I did get a whole number, you could use the Pythagorean theorem. I'm not going to, though. I'm going to use cosine. Cosine of 30 equals adjacent. Your adjacent is little b over your hypotenuse, which is 10. Again, I'm going to multiply by 10. So little b is 10 cosine of 30. This is quicker than the Pythagorean theorem. So 10 cosine 30 is 8.66. And don't forget, on your test, you will have to find the perimeter and the area. So that is also something you guys could be practicing if you wanted to. All right, one more and then we should be good. Again, write this down, pause, try it on your own, and then watch the video to check. All right, let's see. We know angle C is 90. We know side B is 17, and we know side A is 12. So 12 squared plus 17 squared equals C squared. I'm going to use my calculator. 12 squared plus 17 squared is 433. And now I have to square root that. And I get 20.8. Now I have to find two angle measures again, which means I am going to have to use inverse. So I'm going to find angle A. There's my reference. So 17 is adjacent. 12 is opposite. So let's see here. Adjacent and opposite. What uses adjacent and opposite? SOHCAHTOA. Ooh, tangent uses adjacent and opposite. So tangent of A, my opposite is 12, my adjacent is 17. So my angle A is going to be the inverse tangent of 12 over 17. So inverse tangent, 12 divided by 17 in parentheses. And A is going to be 35.2. So 35.2, 90 minus 35.2 is 54.8. All right, so that's going to wrap up the right triangle trigonometry. Tonight you should be working on 5.5 RSG 1 through 14. And then also on our Module 5 page, do the solving right triangles worksheet if you want some more practice. Oh, my mouse is in my way. Go away. So that will give you guys some more good practice. This is on our website for Module 5. There are 4 worksheets there. Do the one that says solving right triangles. You have a Module 5 test review. That will be for later. You have law of sines, and then you have a law of cosines. Those are for later. Only do the right triangle right now. All right, hopefully that helps. If not, you can come in and get some help morning, lunch, after school. You can also ask for some clarification at the beginning or end of class. And I do hope that that helped.